It tells us that Mary and John are working together and the value they can create is going to be split evenly. So we know that value is going to be split divided by 2 for each person. It says they both work hard, total proceeds will be 200. If neither works hard, they'll be 50. And if one works hard while the other doesn't, they'll be 128. So real fast, what we notice about Dr. Dewey's style throughout a lot of these test questions that is very different than the problem sets is that the numbers are nice and round. Because if you look at the utility function for both people, it's the square root of profit minus D, where D is the disutility of effort. Well, the square root of profit in this case, well, if you divide each of those numbers by 2, so 200 divided by 2, that's going to give us 100. The square root of 100 is very easy, it's 10. 50 divided by 2, that's going to give us 25. Square root is 5. And 128 divided by 2, that's going to give us 64. The square root is 8. So he intended for you to be able to do this without a calculator, and that's kind of, you'll notice that all over his old tests. So prepare to see nice round numbers on this final. It says, treating the situation as a one-shot, simultaneous move game, in the Nash equilibrium, Mary's payoff is blank and John's is blank. Well, if it's a one-shot game, we know that each person is going to maximize their one-shot value or maximize their individual surplus. Or they're going to free ride, another way to say the same thing. When they free ride, neither one of them works hard, so for one person, it would look like this. They'll split 50 and get $25, so we'll have the square root of 25 minus 1 because they didn't work hard, and both people will end up making 4. So the answer is 4, 4. The next question says, suppose that there are opportunities to punish partners that free ride, for example by giving bad recommendations. There is no immediate economic reward to delivering such punishments. However, it does cost you something in terms of time and effort. It says that Mary has played games like this many times. She always works hard, and she always has gone out of her way to punish partners that free ride. John is not concerned about his reputation. John believes that Mary will punish or will work hard with probability 0.8 and will actually punish him if he free rides with probability 0.4. So then the question says, so this is the most crucial part, is to understand what the question is asking for, because that's going to be the hardest part to any of these questions, is where do I start? This says, John will be indifferent between working hard and free riding if the cost to him of being punished is equal to blank units of utility. So we're looking at the cost to John, his units of utility, or his units of disutility in this case, of being punished. So it kind of gives us a hint right away. It tells us John will be indifferent between working hard and free riding. So we know that we're looking for John's cost of getting punished, and we're going to be equating working hard and free riding for John. This is going to help us build our story. What does working hard look like? 80% of the time, Mary will work hard as well, and they'll split $200, so John will get $100. 20% of the time, Mary will not work hard, and they'll split $128, so John will get $64. He did work hard, so we have the minus 5, which was the disutility if each person works hard. We're going to set that equal to this side. Well, if he free rode, 80% of the time she worked hard, so he gets 64. 20% of the time she didn't work hard, so they both get 25. And we only minus away 1 because he didn't work hard, so 1 was the disutility of effort if you don't work hard. And then 40% of the time, I'm going to define that as CP, which is the cost of being punished. So 40% of the time, Mary's actually going to punish him when he free rides. And now we're just going to solve this through for CP. We combine like terms, and when we solve this, we see that CP is going to be equal to 4.5.